Hi, and welcome to Lesson 3.3, Adjacent Angles and Vertical Angles. So obviously, based on the title, we are looking at two types of angles. So we'll start with the idea of adjacent angles. So adjacent angles are two non-straight and non-zero angles which share a vertex and a singular side. The common side, so that shared side, must be on the interior of the angle formed by the non-common sides. So to make sense of that, we'll look at the diagram over here on the right. Our common side for angle COB and angle BOA is the ray OB. That is on the interior of COB and AOB combined, because that would be COD or COA. So inside COA, OB is on the interior, making angle COB and angle BOA adjacent angles. They share the vertex and they share a common side that's on the interior of the larger angle. So in example 1, it says, tell why the indicated angles of the figures below are not adjacent. So in part A, it's angle G and angle E. So we're looking at G in the upper left, E in the bottom right. These two angles do not share a vertex, and they do not have a common side. So for both reasons, they are not adjacent angles. In B, angle 7 and angle 8, they do share a common side, which is ZY, but ZY is not on the interior of XZW, the larger angle that they form. So ZY, the common side, is not on the interior of the non-common sides. If ZY was going from Z to Y this way, then 7 and 8 could be adjacent angles. Then we get into the idea of an angle bisector. So an angle bisector is the ray on the interior of an angle that separates it into two congruent angles. So our example over here at the right, ray VR is the angle bisector of angle QVP, because it splits QVP into two equal or congruent angles. And then we have the angle measure postulate. And the angle measure postulate has a key piece, which is the angle addition assumption. So we already looked at some of the angle measure postulates in a previous lesson. Now we're looking at just part E. Part E of the postulate is the angle addition assumption that says if the angles AVC and CVB are adjacent angles, then the measure of AVC plus the measure of CVB is equal to the measure of the larger angle AVB. So CVB plus CVA added together equals AVB, or angle BVA. So in part 2, it says, from the drawing at the right, determine the following. So A, the measure of angle DAE. So angle DAE from D to A to E. That would be angle DAC plus angle AEC, or CAE. So 35 degrees plus 90 degrees equals 125 degrees. Then to figure out the measure of angle BAE, if we drew a circle around this whole figure centered at point A, we know a circle is 360 degrees. So we could inscribe this image inside a circle. Then I know angle BAE is missing a measurement. the other three angles have measurements given. So what I can do is 360 degrees, the whole circle, minus these three angles added together to find the measure of BAE. So in that case, 104 plus 35 plus 90 is 229. 360 minus the 229 tells me angle BAE is 131 degrees. Then we get into two special classifications of angles. We have complementary angles and supplementary angles. Complementary angles are simply a pair of angles whose measures add up to be 90 degrees. So it doesn't matter if they're adjacent or not, but if their measures add to be 90 degrees, they are complementary angles, as you can see with A and B over here. Supplementary angles are two angles whose measures add up to 180 degrees. So looking at our image over at the right, angle A and C are supplementary because they add to equal 180. And then we get into this idea of the equal angle measures theorem. And this is a little bit longer of one, so we'll try to break it down in example 3 here. But the equal angle measure theorem says if two angles have the same measure, then their complements also have the same measure. If two angles have the same measure, then their supplements have the same measure as each other. So if we were looking for a complement to A, we would know that its complement is 30 degrees, 90 minus 60, and we know that any other complementary angle, so angle B is a complement to A. If we had an angle E as a complement to A, that also have to be 30 degrees. Then with C, a supplement to C, we know is always going to be 60 degrees. So if we had another supplementary angle to C, other than A, it would also be 60 degrees, and A would be equal to that angle. So then in part 3, example 3, it says, suppose you're given two angles, A and B, in which the measure of angle A equals the measure of angle B. The measure of a complement to angle A equals 5x plus 20. The measure of the complement equal to B is 3x plus 40. Then they want us to find the measure of a supplement of angle B. So the first thing we want to do is figure out x. And the way we do that is by setting the complements equal to each other and solving for x. So you'll see that math right here. Angle A is complement 3x or 5x plus 20. Angle B is complement 3x plus 40. Set them equal to each other. Then solve for x, and we end up going through the algebra, and x equals 10. Then we want to take x and put it back into the given equations to find the complement's measure. So if I put x into either of these equations, I can figure out the complement's measure. So if I substitute the 10 in for x, 3 times 10 plus 40 is 70 degrees. Or 5 times 10 plus 20 is 70 degrees. So either way, I know that measure is 70 degrees. So then, that's the measure of the complements to A and B. So to figure out the measure of A and B, it would be 90 degrees minus those complements. So 90 minus the 70 told me A and B are 20 degrees. But I'm not answering what's the measure of A and B. I'm answering for the supplement of B. So 180 minus the measure of B gives me the supplement of B. So 180 minus 20 gives me my final answer of 160 degrees. Then we get into the idea of a linear pair or a linear pair theorem. So linear pairs are two adjacent angles whose non-common sides are opposite rays. So if we look at this image over here on the right, we would have many linear pairs, angle BAD and angle BAE. So BAD right here, BAE right here. They're non-common sides, so AD and AE make a straight line or opposite rays. So BAD and BAE are linear pairs, or a linear pair. BAE is also a linear pair to EAC, because BAE plus EAC make a 180-degree straight line here with opposite rays AB and AC. So keep doing that, and we have two other pairs, DAB and DAC, as well as DAC and EAC. And then we have the linear pair theorem that simply states if two angles form a linear pair, then they are supplementary, meaning their measures added together equal 180 degrees. So then we get into example 4, which says refer to the figure at the right and below. So we're going to look way down here. We're looking down at this figure. So in this case, it says if the measure of angle 1 is 52 degrees, what is the measure of angle 2? So to figure that out, angle 1 and 2 are a linear pair. So I can do 180 minus angle 1, which is 52 degrees, and I get the measure of angle 2, which is 128 degrees. If the measure of angle 1 was simply the variable q, how could we figure out the measure of angle 2? It would be 180 minus whatever q is. And then getting into our last concept for this lesson, we're getting into the idea of vertical angles. Vertical angles are two non-straight angles two non-straight angles are vertical angles if and only if the union of their sides is two lines. So if the union of the sides is two lines, we have vertical angles. Now there's an easier way to think of that. If we're looking at an image like this over at the right, our vertical angles would be angle 1 and angle 3, or angle 2 and angle 4. So if it helps you remember what vertical angles are, if we have an X shape, they are on opposite sides of the X. So 1 and 3 are vertical angles, 2 and 4 are vertical angles. Their non-common sides create our two different lines. Line here, line here. Then we have the vertical angle theorem, which simply states if two angles are vertical angles, their measures are equal. Or in other words, vertical angles are always congruent. So angle 1 is equal to angle 3, 2 equal to 4, or 1 is congruent to 3, 2 is congruent to 4. So example 5 says use the figure at the right, so now we're looking at this one down here, to answer the following pieces. So angle 1 and angle 4. 1 and 4 are vertical angles. 4 and 5 together are both supplementary. They make a flat line and a linear pair. So angles 4 and 5 are supplementary plus a linear pair. 3 and 4. 3 and 4 are simply adjacent angles. And 1 and 2 are adjacent angles that add to 90 degrees. So adjacent angles that add to 90 degrees are complementary angles. And then our last piece for today, part E, says if the measure of angle 1 in this image is 35 degrees, find the rest of the angle measures. So if I know angle 1 and 2 are complementary, that means they added together to equal 90. So 90 minus angle 1, which is 135, gives me angle 2 of 55 degrees. Then once I had angle 2, I could also figure out angle 3, which is real easy. They gave us the right angle symbol. So angle 3 is 90 degrees. Angle 4 we can figure out because it's vertical with angle 1. So 1 and 4 are vertical, meaning they're equal. So 4 is also 35 degrees. And then angle 5. Well, angle 5 is a linear pair with 1 and a linear pair with 4. So that means 5 plus 1 or 5 plus 4 is equal to 180 degrees. So 180 minus angle 4, which is 35 degrees, leaves me with the measure angle 5 at 145 degrees.